Hello everyone, I'm back once again with the next video, and today video is really very interesting because we are going to learn about predictive analytics, the regression part. In this video today, we are going to learn about how the analytics part actually works. What is analytics? Analyzing the data. When you have the data, you can even describe the data just to see where you are standing. If you want to monitor the health of your system, you present your data into the dashboards. For dashboard making, we have various tools we use with Excel, Power BI. So that is called as descriptive stats or descriptive analytics. But do you know, from the data itself, you can predict the future? Yes, it's possible. How? So assume, let's take a case that I'm having a business problem that I have a high attrition. If I want to solve it, how I would be solving that? I would be first thinking that what are the parameters that is making this attrition happen? Probably I'm giving less salary. Probably employee satisfaction score is less. And after getting those all data sets, I can really predict that how much things I need to change, with how much percentage that can give me the better solution to my business result. This system of predicting and solving your business problem is called as predictive analytics. For predictive analytics, there are various tools like R, you can use with a programming language like Python, but for our HR, there is a very simple technique, we call that as a regression analysis. Either it's a business problem or you want to predict the future, we use predictive analytics for that. So today we are going to learn how predictive analytics works and what are the different steps of the predictive analytics. So let's go and let's start learning. Hello everyone, now let's start learning about the predictive analytics. This means analyzing the data. Now, after analyzing the data, you can even predict for the future. That's your predictive analytics. When you are describing the data in the dashboards, that's your descriptive analytics. After describing the data, you will come to know where you are standing, what's the health of the system, and you are able to diagnose the problem. That's a diagnostic. And after the prediction, you take an accurate step to improve the problems. That's called as prescriptive analytics. So analytics in HR is of 4 types: descriptive, diagnostic, predictive, and prescriptive analytics. So today our main focus is to learn about predictive analytics, and the technique which we are going to learn is called as regression analysis in prediction. As explained before, why we need to do the predictive analytics? Either I have a business problem, I want to solve it, that why it is happening, which factor is making the impact, or I really want to improve my system. For both of the things, we use the predictive analytics. The anatomy of any statistical model is, first we have to understand where is the problem. Then for that problem, what could be the relevant factors? We need to gather the data for that. Then we need to prepare the data, find the best algorithm. Now today we will be learning only regression. So our model is just regression on step 4. And then we are able to do the right predictions. The first point, understanding the business problem. How? As in the beginning I explained you, I given you an example of attrition. So what's your business problem? Attrition. Now let's take another case study. Let's assume that there is a e-commerce store. Their business problem is the people are adding the products in the cart, but they are not buying it. So their business problem is the products are not getting sold from the website. Now the second step is gathering the data. Think, if the product is not able to, the customers are not buying it, what could be the factors? What data you need? You need a data which are related. Example, might be there is certain product value that is more. The UX part is or UI part is complicated. People are not able to understand. Or people just don't want to
pay it later, they just want to add it. So you need a data related to these segments, like after how much value the people are not buying it, what sort of people, male versus female, not buying it. Then you have to do the customer satisfaction or UX survey to see. So these all data will help to find your real problem. That's called as gathering the data. When you have a business problem, you in predictive analytics, you can compare always with the outside world. You can do it with, if your company is big, you have enough data. You can do it within your data, but within your organization. But yes, we always recommend that it should be the sum of both outside baseline data, benchmark data, as well as inside data. So I would take what other competitors, how much is their customer satisfaction score, how is their UX, are they also facing the same problem, after what amount the customer don't want to pay online. So if I'll get this all data, that step is called as data discovery. Now let's relate the same thing with our HR model. My business problem was attrition. So attrition could be related with my employee satisfaction score, right? What else? The salary benchmarking, correct? Your engagement activities, how many you are giving? What is the average stay of the employee in one designation, means what's your promotion or a appraisal percentage or a rate. So if these are the points which is related, what I will do, I will float a survey that and I'll try to gather the data of 10, 15, 20 or let's say 1000 organizations. If the employee satisfaction score of a company 1 was this, and what was their attrition rate? Company 2 was this, what was their attrition rate? Like that, I will find the data. Same way, I will get the data. What is the average salary they pay and what's their attrition rate? But make sure when you are running any stats model, anything in stats, you cannot run on the smaller data set. The bigger data, the right prediction. So always try to go more than 10,000 data. That's the general number we say in stats, but yes, the bigger data, the accurate results. That's what you need to focus on. So what we learned so far, we first need to understand what's the problem. What are the factors that is arising the problem? Or let's take in another way. What are the things that you want to improve on? And what are the things which is related to that? And what's going in the market for that? You have to float a survey and gather the data. Now the third step is preparing the data. When the data will come, the data could be in qualitative format and a quantitative format. In our next video, we are going to learn about regression. So we cannot run the regressions on a qualitative data. We have to prepare the data. We need to remove the outliers, missing numbers. We have to convert all the qualitative data to the quantitative format. Then our data will be perfectly ready for the analytics. That's called as data filtering or data preparation stage. The fourth stage is our regression and fifth stage is our prediction. So in any predictive analytics, we follow the 5 stages of analytics. Right? Now we are going to learn how we can run the stage 3. Now in my case study, I am just trying to find a solution of CTC. So the problem is that I don't know if the city change, if the designation change, if the person is coming from the different background, different good college, what is the average percentage change that's going in the market and how much plus minus I should give. So that's my business problem. So what are the different factors that's related to it? The city, the college, the first job, CTC when the employee started, how many job changes, the graduation scores, the total experience, the current designation and the final CTC of the last job. That all are my related factors. So let's say I want to solve it for the PHP developer. So in PHP developer, I have two designations, one for at the executive level and one at the manager level. So I floated a survey on LinkedIn and I got the data. I told all the PHP developer to fill the data, what was their first CTC, how many job changes they did, what was the graduation score, from which city they are coming, and I got this entire data which you are able to see on your screen. Now if you were to analyze, I have here, this is college, the tier 1 college, tier 2 college, tier 3 college, the role, whether they are executive and the manager role, and whether they are from the metro city, non-metro city. And then we have the first job, how many job changes they did, the graduation score, the experience months, and CTC. For now, I will delete these columns for you. We will do it in the data preparation. So this is the rough data I have, right? What I will do, the first step, these are the 4 steps that helps us to clean the data. The first step is whatever in your headings, or we call that as a labels, there should not be any space. If you would have analyzed already, it is not city type, it is city underscore type, previous underscore CTC, previous underscore job underscore change. So wherever there is a space, you have to change the space with a underscore. That's the first step of data cleaning. The second step of the data cleaning is you have to find for each column, just see the total count and make sure there is no missing numbers. So if there is a missing number, you have to always replace that with a 0. The third step, find the outliers and treat the outliers. Now the question is, what is an outlier? Let's take an example. It's Diwali season. There is a shop, the data is of shop, and it's a Diwali season. Suddenly the sale has been jumped to 13-14 times. So do we feel the same? That's an average sale? No, it happened because of some specified reason. And if I will do the average of entire sale and I will take that data also, then my average will be wrong, correct? So sudden spike due to some temporary situations is called as outlier. Let's say your average CTC in normal distribution is going around 2 lakh, 3 lakh, and suddenly there is 20 lakh. So obviously 20 lakh is an outlier. If you will take that data and you will not treat it, your average results will differ, right? I hope we are clear what's an outlier, correct? Now we have to treat the outlier and then we have to run our analysis. How do we treat the outlier? When we have the data, the first point of the data always is we need to install the data tool. So once it is installed, it looks like this. Now there are two options, descriptive stats and predictive stats. Descriptive stats, you need to see that where you are standing, means what is the outlier, whether your data has an outlier or not, and how do you treat the outlier. So there is an option descriptive stats, whether this data, let's say I am putting it here. Now this is an outlier, correct? Now let's say I have input the outlier here. It's a small data, you are able to see it clearly. But when you have a big data, then finding the outlier is not that easy and treating the outlier is not that easy. So you need to install your analysis tool pack and run the descriptive stats first to see whether your data has an outlier or not. If yes, you have to treat the outlier. So let's say my input range, I want to see it from here to here. Is there an outlier? Output, I'll do it here only. Okay. So I got the output. How do we read the output? Can you see there? It's the maximum. That's our outlier. Now understand our kurtosis and skewness. There are two things to check that whether the data has an outlier or not. If the mean and median difference is too much, usually they are around the same. If it is too much, then that means the data has an outlier. And also kurtosis skewness are always either -1, 1, 0 point something, maximum 1. If your kurtosis skewness are going above 1, 2, that means there is an outlier and maximum is your outlier. So when you have found your outlier, we need to treat the outlier. So the data, whatever you have selected, you can take any data from the first percentile or the last percentile, multiply by 3. Example 6508 I picked. Multiply by 3. 19524. You have to always replace your outlier like this. So let's recap till now what we learned. The first step of data cleaning is there should not be a space in the labels. There should not be a missing numbers, replaced with a 0. There should be an accurate, the count should be the same. Fourth step is there should not be any outliers. If there is an outlier, you can find the outlier from the descriptive stats. If kurtosis skewness is going high and if the mean median difference is high, that means there is an outlier and you have to replace it, multiply by 3 and replace it. From any number from the first percentile or the last percentile, replace it. The last step of data filtering is converting these all qualitative data to the quantitative format. Now we have college in the qualitative, role in the qualitative, city type in that qualitative. So how many data sets you have? The formula is that n-1. Suppose 3 data sets I have, I need to create a 2 column. 1 column, 2 column. So first is for the college. So I'll create first column for tier 1. The second column I'm creating for tier 2. So simple if formula we will put. If this is tier 1, give me 1, otherwise give me 0. So all the qualitative data we have to convert into the segment of 1 or 0. Right? Understood? So if this is tier 1, then give me 1, otherwise give me 0. Same if this is tier 2, if this is tier 2, give me 1, otherwise 0. Right? So my 0, my Excel setting, it is replacing with the hash symbol, but you can always change it with your zeros. Understood? Now same way, this is a qualitative. Here there are 2 qualitative data sets. So how many columns I need to create? 1. 1 column I need to create. If there are 2, I need to create a 1 column. Same way, if this is executive, give me 1, otherwise 0. Here also we have 2 data sets. I have to create a 1 column. If this is metro, give me 1, otherwise 0. So all the qualitative data has been converted to the quantitative data, sorted, prepared. So this is the first step of predictive analytics called as data cleaning. So data cleaning has just replacing the spaces with the underscore, no outliers, no missing numbers, proper counts, changing all the qualitative to quantitative, treating the outliers. So that was the agenda for the today's class, today's learning. Tomorrow, once our data is prepared, now we will run our regression analytics on that, and we will do the prediction that yes, if my CTC, if my city is getting changed, how much more percentage of the CTC I have to offer.
So today we are going to practically run the regression analysis and going to see how it is helpful for a business problem or a HR problem. So let's go and let's start learning. Hello everyone, welcome once again, and now we are going to practically learn how to run the regressions. In the last video we have learned how to clean the data. So once the data is cleaned, it's in front of us, the data is there. So we will take the data from here. I will not take this data because it's not been changed yet. These college, role and city as a qualitative 0-1 format. So with a few column examples, we will be running the regression analysis. So as I said in Excel we have a tool pack. In the tool pack, you have an option of linear regression. First, linear regression runs on the two axes, y-axis and x-axis. What is y-axis? The y-axis is the data which is ultimately your output. As my business problem was, I want to see how much on the last CTC hike I have to give on the dependent variables. So y is my last CTC. So dependent variable could be my first CTC, how many job changes the employee did, graduation score. So these all becomes X. This is Y, this is X. I'm doing the regression on a very simple 5-10 numbers, but when you do the regression, you have to take a big data. So Y, let's say these 21 number, X. So I want to see whether graduation scores or let's do it for 21. So the more X's you can take, that's not a problem. We are doing it on a short data just to make you understand. And here I want an output. So we got the output, right? Now see here, first what thing we have to check. First, we have to see the R square. That helps us to understand that whether the analysis, what you did, is that analysis making sense? We did it on a very smaller data, only with the two numbers, so it is not making sense because it's 0.33. As it will go higher than 0.65, more than 65%, that means your data, the next prediction is good to go. In this segment right now, it is 0.33, so this data is not good. I need more numbers to have a right prediction. But let's assume if it is a right prediction, then what is the next thing we need to go? Then the second thing, we have to check the p-value. The closer to 0.025 data, that makes more impact on the data. So that means experience is making the impact on the salary. So if 1 month experience, because we have a data in months, so if 1 month increase, I have to give 387 rupees. So suppose a one employee coming with the 11-month experience and second employee coming with the 12-month experience, their salary difference has to be between 387. So with the 1 month difference, it's 387 plus you have to give. This is how we predict the data in regression analysis. This is called as beta naught, beta 1, beta 2. So first, from the p-value, we will come to know what are the factors which really is making a sense, making an impact on y. And then the beta coefficient will help us understand how much. Got it? So that was about the regression analysis. And I am looking forward for your comments for the next videos. Do share the video with your friends. Don't forget to visit our website www.theskillrec.com and do visit our application. Download our app of SkillRec to buy any pre-recorded courses. I'll see you in the next video. By then, take care. Bye-bye.